Imagine business changing the requirement to switch from an email notification to SMS notification, and you as a developer go about thinking what problem might be caused because you will have to touch that core code again. Welcome back to another video on object-oriented programming using C#, and the topic for today is Dependency Inversion Principle, also known as DIP, the D in solid principles. Whenever there is a change in the requirement, if you have to touch your core code, this moment captures the pain of not following dependency inversion principle. The core business logic is directly dependent on low-level implementations, in this case email notification. This means even a small change in notification type forces you to change your core code base, increasing risk, reducing maintainability, and violating even the open-close principle. Dependency inversion principle tells us to depend on abstractions. I repeat, to depend on abstractions like interfaces and abstract classes, and not on concrete implementations. That way, changes like swapping email to a SMS or even to a push notification will become a plug and play. Later in this video, we will see how we introduce the abstraction to isolate your business logic from this kind of changes, making your code flexible, testable, and future-proof. Let's get started. Now, this is how we solve the problem using dependency inversion principle. Instead of the core logic directly depending on email or SMS notification, we introduce a common abstraction called iNotification service. This interface acts as a contract which defines what should be done, like send notification, without caring about how it has to be done, which is the responsibility of a concrete implementation. Now, whether it's an email, SMS, or push notification, each one becomes a concrete class that implements this interface. They are swappable behind the scenes without affecting the main logic. This is the core of dependency inversion principle. High-level modules like business logic should not depend on low-level modules like SMS, email, or even push notification. Instead, both should depend on an abstraction. And we flip the usual dependency direction. That's the inversion in dependency inversion, because instead of core logic knowing about the details, now the details confirm on the needs of the core logic. This gives us flexibility, testability, and clean separation of concerns. If there is a new notification type that's added tomorrow, just plug it in. No need to touch the core logic. All right, now let's take a quick look at the kind of code we usually get to see before applying dependency inversion principle. We start with email service class. It has one job, that is to send email. The method send email takes a recipient and a message and just writes it to the console. Then we have notification manager. Now here is where the problem begins. Look at the line inside the constructor. This is what is called tight coupling. The notification manager class is directly tied, or in other words, directly married to email service. It creates it, it holds it, and depends on it. This means if tomorrow, if we want to send SMS or a push notification instead, we will have to modify this core class called as notification manager. And that violates even the open-close principle. The class isn't closed for modification. So any new notification method like SMS service would require us to add an if statement or replace the email service code entirely. That is hard to maintain. Not just that, it also makes unit testing harder. You can't easily mock email service because it's being created directly inside notification manager. How can we mock something in which the object itself is created inside notification manager? And in the main method, we just create notification manager and send an email. This works, but it is rigid, not scalable, and violates dependency inversion principle. Let's now refactor this code using dependency inversion principle and watch how things becomes cleaner, more flexible, and test friendly. Let's get started. Now let's look at the refactored version. This is what the code looks like after applying dependency inversion principle. We start by introducing an abstraction called iNotificationService with the method notify that takes a user and a message. This is the contract that all notification services like email, SMS, or even push notification must follow. And this is the essence of dependency inversion principle. High-level modules depend on abstraction and not on concrete classes. Next, we have our email service, which implements now the iNotification service contract. Inside it, we define the logic for sending an email. Now, here is the real change. Look at the constructor of notification manager. Instead of creating the object of service itself, it expects the abstraction to be provided now. It expects for iNotification service to be provided now. This means the notification manager doesn't care how the message is sent. It just calls service.notify. That's it. Now you can plug in email service, SMS service, or even a mock notification service for testing without touching even a single line inside your core notification manager class. This change makes the class easily testable. How? In unit test, you can inject a fake or mock implementation of iNotification service and asset its behavior. This is how dependency inversion makes your code more flexible, testable, and maintainable by flipping the direction of dependency from low-level details to high-level abstraction. Now let's look at the benefits of applying dependency inversion principle. We will be able to swap implementations easily, need to switch from email to SMS or maybe even push notification. With DIP, you just swap one implementation to another. No need to rewrite your business logic. Unit test with mocks. Since your classes depend on interfaces, you can easily plug in mock implementations during testing. No need to send real emails just to test logic. You test in isolation with full control. Loosely coupled architecture. This principle enforces a separation between what your system does and how it does. The result, a loosely coupled architecture that is easier to extend and safer to modify and easier to maintain. Better scalability. As your application grows, adding new features becomes simpler. Want to introduce a WhatsApp notification or integrate with a third-party service for a different sort of notification? You won't need to change your core logic. Open to change, close to breakage. This is the dream. Your system is open to new changes, but protected from breaking existing code, existing tested code. DIP keeps your code stable, extensible, and future ready. So the next time you find yourself hard coding dependencies, pause and ask, can I invert this dependency and code to an abstraction instead? You will thank yourself later. Thank you for watching our video and do subscribe our channel for more such videos, and thank you very much for your support.